Yeah, so never mind the Bezier fitter yet. Now I'm going to work on this class. But I'll start with a commit. Ugh. uh, Okay, so what kind of operations do we want on this thing? Maybe let's add nope. Did I close that? I closed it. Stupid. Yeah, find it again. BezierCurve formula, which would work. No, I had a stack exchange thing about a derivative, I think. Holy bright. Yeah, this is for too many. Yeah, guess that should do. It's still no. Let's try find the. Damn it. Let's go straight. Just looked at it. Also, just looked at it. Yeah, I should not have closed that window. I'll just derive it myself. Let's begin with the... I do want to get the formula. Let's use side stack overflow now. Okay, this was the formula that I was looking for. I think anyway. This is better. See, I did get confused, and maybe I'm still confused. Here's two pluses, yeah? Yeah, 1 minus t to the power 3 plus 3 times 1 minus t squared times t, and the other way around. This one squared, that one not, and then t to the power 3. And there's a 3 here and a 3 here, and only pluses. And then I see this code and I say, hey, this is what I was looking for. But there are minus signs in it. I don't know what it is actually. Let's go for this one. You even get the derivatives now for free. Yeah. I don't know why I copied this, but... clicked on it. Okay, so I just did it in 2D. So that each point here is X and Y coordinate. I have no idea why this guy does it separately, because he's talking about the X coordinate here, and then here again the Y coordinate. But you can just combine the two and write everything as a vector. It's the same thing, you know, the same vectors here. So if the X coordinate is multiplied by that and the Y coordinate too, then you can might as well talk about that vector times a point, right? Times a vector, a 2D vector. Yep, and so far I worked with polynomials in T. So we write this out, you get one minus 3t. Oh shit. It's now, my headphones are broken. Where's my phone? Oh, no phone. I need to buy a new thingy for my headphone, but I can't even find it online. I just want to replace the cable. The cable is broken. If I move too much, then I don't have music anymore. I have to admit that doing this per point is a bit confusing, because now we get nonsense. Let's just write it out. From memory. I mean, that's correct, right? Fuck it. I'm 99.99% sure. Which is not enough. Okay, 99.999. Still, it's not a waste of time, because making a mistake during calculations is okay. It was correct. The odd one says I have a minus, and there's a 3 here. Well, times B0, of course. And then this is 1 minus 2t plus t squared. Yep, that's this one. Times 3. Mouse is broken as well. I'm not asking ChatGPT to be anything anymore. Certainly not mathematics. Yeah, that can't be right, of course. I've got a t here. This must be multiplied by t. 2. Oops. And this one is multiplied by yeah, the t squared, so call that one right. Errors. Did I do it correctly? This one was correct. Plus 3t So it is minus 2t minus 260 minus 26t squared. Yeah, well, can't make anything else of it. Plus t to the power 3 p1, okay. 3t squared minus 3t to the power 3. Looks okay. P0 plus 3 times. This one is minus 6 P1 minus 6. This one is plus 3 P2. 3 times P2. And that's it. Anyone sees a mistake, please scream. T just the 3 times and another 3 there. Let's again do the 3 here. Let's put this one first again. So that's a T, so 3 times P1 minus 3 times a P0. And then finally we have P0, and that's it. Now I have a minus P0. It's already different. Well, I did compare it, but you said plus P0 and so on. So I don't know. Well, we should be able to find this formula as well, of course. Somewhere online to check it. Did you ask ChatGPT? Because ChatGPT doesn't know the difference between a plus and a minus. Yeah, I should be able to find it on Wikipedia. Don't tell me they don't write it as a polynomial. Seriously, they didn't. They don't. Clear formula here. Huh? Didn't help. Here we are. We think, at least. Nope, not the same. Oh, no, it's not the same. But then again, they don't even have a B0 to begin with. This guy doesn't. Everything was had a factor of chi. Unbelievable. Oh, fuck it. I have it, or I have it myself. Let's just compare it with my own code for the cubic Bezier. Oops, which file was I editing? Oh, this one. Oh no, I did all kinds of things, but not. No, I didn't. I don't have it. No, get it. Yeah. That didn't help. Now I still have to combine everything. Dude. And I didn't really see it ask Wolverine. Let's try this again. Oh fuck. I was here. Oh, shit. Stop. Ask the rock first. What the heck is it doing? Finally. Minus P0, yeah. Plus 3P1 minus 3P2 plus P3. All that is correct. And then here we have the T squared one. I have P0, which is, times 3, yeah, 3 times P0. Minus 6 times P1 plus 3 times P2. 3 times P1 minus 3 times P0 plus P0. Yay, I did not make a mistake. Okay, so let's say we do everything as a vector, so as much as possible anyway. I store it in this form. Maybe we should call them C, as control points. Yeah, why not? They're private anyway. Oh, not private. This is exposing my change. So as matrix form, I have then the first column of the matrix. How shall we call that? M0. Whatever. First column of the matrix. P0. Yeah, mine is 3 times P2 and plus, so minus minus 3 times P1 minus P0 plus P3. 3 times P2 minus that plus that. What is this? Minus P0 times 3. Okay. There are shitloads of things that we want to do. Like what? Oh, you're right. Maybe also here then. Maybe that wasn't a good idea to name them C. Oh well. Can also rename it back, right? P1 becomes C1. Oh, I lost my one. Two. me think. Oh yeah, but like I said in the description, I want to calculate the extent. Maybe some simple things first, like the derivative. Do I even want it? Well, why not? Can always add it, no? The point, let me see, we can... Value is like the lamest thing I ever invented here. What is a better word? A better word than value? I'm using P here. Maybe I should use that. Because this is the most efficient. First calculating this as a double, and only then multiplying it with the vector. I'm needing a t squared. And a t to the power 3. And a 1 minus t. Squared. Can't type. Really? Ridiculous. Is that not a better way to do this? Just gonna use it too here. Don't want to use that, but what can you do? Cairo, yeah, you can. I don't think so. I mean, you can do that if you use the other one, this one. But then I would have to calculate a lot of vector stuff. Well, 3 times actually 2 multiplications. And this addition is 2 additions for the x and the y coordinate. So I'd rather use this one. Oh no, you can't do that. I think I did not make a mistake here. 1 minus t to the power 3 times b0 plus 3 times 1 minus t squared times t times c1 plus 3 times 1 minus t times t squared times c2 plus etc. Good. Good. Okay, what can we do next? What about the direction vector? Or just the velocity, maybe? Yeah, why not? I mean, maybe I don't need it, but might as well add it. So it's just the first derivative. Maybe I should first. I want to do the same thing. I wanted to have it in the first form again. Maybe you should write the velocity formulas here as well. That's a derivative of this. Derivative of this is even more difficult. Might as well work with this. It's probably easier. Or not. Yeah, that's the same as this. I guess it's easy to get the derivative of this, but then going back to how do you call it? I would almost say polynomial of two variables, t and 1 minus t. I think I want to keep it that way, so maybe I should just take the derivative of this. So 3 times the derivative of this times t. So that is 6 times 1 minus t times minus 1 times t plus that. I'm not impressed with this. Now let's write this a polynomial in t. Let's take the derivative of this thing here. So that's 3 minus 12 t plus 9 t squared times c1 . Yeah, well, I stored them like this, so I have to work with this. Hardly makes a difference. Just keep it like this. Okay, I'll just write this one out as well. So the derivative of this minus 3 plus 6t minus 3t squared times B0. The whole thing is very much divisible by 3. But there's only one factor of 3 here. Well, there's a factor of 3 here, but you hardly gain anything by... Yeah, well, I don't know. Would gain a little bit. So we'll leave it like this. I have to do twice a multiplication with 3. And if I first add everything and then multiply it by 3, the whole thing, then it's just a single one. This should be a quadratic Bezier curve, well, obviously, because you lost a t to the power 3. So you can write this again as power of t, power of t, power of t, power of t. There's a power of t, there's a non-power of t. The C1, no, yeah, okay. 3 times C1 minus P0 plus here's a T, and here's a T, and here's a T. So that's 3 of them. That one's negative. Let's start as before at the end. C2, 6C2 minus 12C1 plus 6P0 and then finally we have a t squared existing also 3 times P3 square minus 9 C2 plus 9 C1 minus 3 P0. 6 times that. Totally going to get him outside here. I think the acceleration is completely useless. I tried to use that, or at least the curvature, but it is so useless. Did you see that Kotaro? I suppose you didn't. Let me show you. So that's my... What the fuck? No, it doesn't compile. Because I'm in the middle of something. No, okay, let's finish this one. Velocity is I'm going to use this one. It's also a minus. this -3 out of it. Okay, Kotaro, look at this. What this is doing is fitting a cubic Bezier curve through the big start point and the end point. And, of course, having the same derivative as the previous one, so I can just change the derivative here. Also be continuous in the second derivative, so the curvature is the same, which I just specify here. I mean, the same as the previous one. Previous does not exist in this test. I just specify it. So this is my curvature. So you can make it very curved or not very curved, or the other curved the other way around. But and that, well, the idea was that I change beta, the last thing that I can change, such that it goes through this point. Okay, so cubic Bezier curve defined by 8 variables, 2 for each point, so 1, 2, 3, 4, 5, 6, and then 1 for the direction, that's the angle, and then 1 for the radius here, the curvature. But does that give me a good fit? No, not at all. look what happens if I try to fit this curve through P gamma by changing this. That's like absolutely horrible curve to fit between P0 and P1. No fucking way, man. What you want is something like, I don't know, something else than this. And it even gets worse if you put this point, I don't know, higher. Shut the fuck, dude. It really takes, you know, it takes a step back. So, you know, like, go far away and then reapproach the stuff again. I think the whole problem here was it goes up and then say P1 goes down. And then we have to go up again a little bit, something like this. This is bullshit. This is bullshit, dude. Or if the curvature is very small, yeah. No. You know, fitting it through. Oh, and I didn't even, I can't even get it to, let's put the point there, so. Oh, this is a nice example, right? So, okay, the curvature here was very high. And then for a cubic Bezier to have the same curvature and the same direction in this point given, and then go to those 2 points, it has to, like, go way back and then yoing, then from there it can go through it. Or I had it like this, it was even worse. I don't know why I can't get that anymore. It's more like this. The curvature was like, the curvature was positive. See if I can get that. No. No, I don't know. Does it look the same as what it had before? Maybe on this one up. No, it doesn't even look that bad. But anyway, this convinced me that the whole using the same curvature is not good. The cubic Bezier is just not good enough. Does not have enough variables to let it make sense. It has to twist itself, go far away, just to be able to hit both points. And then, well, the curve, this direction here is the velocity, right? Or at least the direction of the velocity. So the first derivative, and the curvature has to do with the second derivative. But yeah, I'm just forget the derivative, you know. I'm not, I don't. Cubic Beziers and second derivatives, they don't work together. So I'll leave it at this. You can get the velocity. Or the velocity isn't even very interesting for me. Let's say our Bezier curves are used, for example, for camera movements. And then, of course, you want you know, the camera to move smoothly, where t is then the time. So then you are really interested in the speed. You don't want the camera to move slowly and then reach a certain point and then suddenly start moving faster. But for this application, I'm only interested in the trajectory, not in the velocity at all. So I want the curve to go in the same direction, but I don't care how fast it goes relative to t. So I just take the direction vector of this thing, which then changes it, you know, from 2-dimensional to 1-dimensional. The velocity is, of course, 2-dimensional. It's a vector. But yeah. This is almost like an accessor, right? You just, if the thing is defined, we already constructed it, like with, yeah, the thing is completely defined. Well, you can ask back, begin endpoint, control points, or in matrix form, and the value, of course, and the velocity, and then you have everything, because I'm not going to return the acceleration. That's like all there is, isn't it? Except, well, yeah, once it is defined. But now we have also the problem that it isn't defined yet. So let's say we create a Bezier curve from only 2 points. No control points. We don't know the control points. I might maybe I should add another constructor to fully define it from the matrix values, the matrix columns. So you pass in these, and then I have to do the reverse of this. If you want to help, do that part for me, please. I'll do something else. Okay, do that. Write constructor for me for which takes in M0, 1, 2, and 3, and then initializes these values. Oh, you laugh, so I'm gonna assume that you are not going to do it. In which case I have to do it. Not difficult. M0. I could do that one. The reverse of that. So then, then we can do C1 as well. No, I don't. But this is one easy to do. If you have N1, and I want to have that, so divide M1 by 3. I can't divide it. Shall I add a division? I'm gonna add a division, I think, because I refuse to type 0.333 one more time. Why am I typing M3? M1. So M1 divided by 3 is this. So we just add P0, which is equal to, well, I just defined it. Can even do plus P0, because I just initialized it. That's the reverse of this one. And then C2 would be, well, we can then go ahead and calculate C2 from here. It's again divided by 3. So M2 divided by 3. That's this. So plus 2 times, well, that minus whatever. M2 divided by 3 plus 2 times C1 minus P0. Yeah. And then here we have the last one. That gives me P3. M3 plus 3.0 times that plus P0. Okay. Now let's add that division, because I can't do vector division. Cannot be redeclared. What kind of nonsense is that? Oh boy. Oh boy. So I'll make these points. It's a bit random, right? I mean, so far I used vectors for everything. It's very random. Plus, if now you use vectors for this one, and you get that one. So it's probably also not what I want. We keep using vectors. I just have to do something about this one. Int, whatever. Or maybe I should pass an actual matrix. I would have to change a lot of code if I want to start using a real matrix object here for the Bezier curve. But the right way is the long way. Gotta make it destructive. Maybe M is now not the right thing anymore. They are not matrices, they are columns. Or they are polynomial coefficients. Why does it have to be a C? Everything is a C here. There's no way around it. Column, coefficient. Yeah, you think that is better, huh? Well, then I could index them. That is that kind of better than just having 4 variables. But I don't use a standard array. A standard array really sucks. I mean, everything has to be a class. But I kind of agree with you that it has to be. It would be nicer to have an, you know. Like that, I guess. Type. But yeah, now it's a long word. Coefficients. Well, it is a struct. Maybe I should make it coefficients. And without underscore even. So yeah, it's 2 characters shorter. And then here you have the problem that I want to substitute dot c 0 through 3, I think is the maximum, right? Underscore with m dot coefficient. Nee, not that bad. Now let's fix that division there. Or not. Or not. First, let's first fix everything else. That's it. Too many errors. No memory coefficient in Cairo window. Do you mean coefficient? Yeah, no, I didn't. This is just spelled wrong. Up there. Coefficient, right? And now finally we have errors just complaining about the division. Great. Value and vector. What? No, vector and double. Vecteuren. I can multiply, we can do everything. Multiply with a double from the right, from the left, I mean. I can also, yeah, from the right. So I just need this one. No, I don't need this one. It's got to be a friend. No, it's got to be it's got to be an Alzheimer's coming. How do you call them? No. You have a unary, it's just an operator, a binary operator? Really? I think that's what I meant, yeah. It is also a free function, but I meant... Yeah, actually that's more precise even. We could make it a non-free function though, because the factor is definitely on the left. And it's asymmetrical. Well, let's do that. just gonna return. Just constructed in place. Yeah, if I add that, I have to add this one as well. Not using it yet, but should I support multiplying it from the right with the scalar? I can do it with from the left already. I think I don't want to edit that yet. What? Invalid operands of binary expression? Well, I made a mistake with the const. I did not make a mistake with the const. Well, actually I did. But still. Why would I? Do I have something that is const? No, whatever. I guess this fixes it. Yep. Okay, and now finally we can continue something serious. Vector, let's go to BezierCurve. Why is it so fucking late? Yeah, let's write something that initializes it. So begin and endpoint we already have, but now I want to pass I mean, I did a lot of work. I don't want to throw all that work away. So I could do can do 2 more data points. No. What else did I do? Well, 1 data point, of course. Oh, of course, yeah. The last thing that I did do, but it wasn't very useful. 1 data point and the curvature. I wasn't going to do the curvature. It just doesn't make any sense. Let's forget about that one. Oh, wait a minute. Actually, quadratic makes sense. Quadratic makes always sense. Still confused me. 2 more data points means we have 4. I'm not even sure I can do this, but this is so weird. This is so confusing me. Look, if I have quadratic, I'm not sure if I did it here. Yeah. Look at this. 1 data point, 2, 3, 4. 4 data points. And this is a quadratic Bezier, so it's a parabola that goes through it. And you can draw a parabola through it. Oops. You can draw a parabola through this for, well, wherever you put those points. And you can say, yeah, but you can't drag or change P0 and P1. That's true, but I can scale the whole thing to make the distance whatever I want, and I can rotate it. And then I can translate it. That doesn't change the shape of the parabola at all. So I can put P0 and P1 wherever I want. Now the confusion is that, you know, you understand, this is a parabola, okay? The parabola fits, okay? If now I scale the whole thing, the x and y, x and y with the same scale, so you just zoom in and zoom out, then of course it's still a parabola and it still goes through those points. If I rotate the whole thing, same thing. Still a rotated parabola, still going through those 4 points. And if I translate it, just move it around, it doesn't, I can do it like this, you know, that doesn't change anything. Still a parabola, still going through those 4 points. Therefore, I can put P0 and P1 anywhere where I want. And then, of course, because I can already put these anywhere where I want, I have 4 data points, which I can put anywhere where I want. And a parabola fits through it. I mean, a quadratic Bezier curve. A rotated parabola fits through 4 points. The confusion here is that 4 points means 8 variables. Yeah, x and y for each point. 8 variables, that's a cubic Bezier, not a quadratic. A quadratic Bezier would be defined by 6 variables. So how is this possible? How on earth can I fit a parabola which is defined by 6 reals? Yeah, but this is not a this is a quadratic Bezier, really. It's not cubic. It's totally a parabola, this thing. You see, it looks like a little bit rotated, but it's a parabola. The only thing is that you cannot put them anywhere you want. If I put this one too high, then there's no solution. So at some point, just there is no parabola anymore. What happens is you go up, 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 and then it collapses the parabola into. Oh, it got cut off now, but it makes it super thin until it's on one line, and then if you move it higher, there's no solution. So you have to stay below this line. But then there is a lot of wiggle room until this point. Till it's again an infinitely long parabola. That's just 2 parallel lines, and then there's no solution anymore, or not a good solution anyway. Now the P-com is in between P0 and P1, P-bad as well, by the way. That's not the correct solution. Yeah, this too. Sometimes they draw something, but it's not correct. It must be like this. First P beta, then P0, then P1, and then P gamma. A rotated parabola again can go through a few 4 points. Clearly. But the only thing I can think of is that it has to do with the fact that I put P0 and P1 on fixed points. I mean, by putting those on fixed points, the matrix of the quadratic Bezier is 2 by 2. So I have 4 reals. 1, 2, 3, 4. So I have only 4 input variables, 2 of those and 2 of those. And that defines my my 2 by 2 matrix, which is a rotated parabola or a quadratic Bezier. But then, you know, like I just said, I think I can make this work with a P0 and P1 draggable as well. You just have to do some coordinate system transformations, fine transformations to get it to this point. Then I can calculate it and then translate it back, transform it back. So I don't know, really weird, really weird. Can't wrap my head around this. Why? Anyway, this might be useful. So that was my first member function that I still have to implement then. To just specify 4 points and draw a parabola. But I'm like, yeah, is that even possible? I mean, I prove it here that it is possible. But why is it possible? It's so weird. And the other one is where I specify not P beta. I think I have to go to the cubic one then. Rather, oh no, yeah, this is it. The other one, is it quadratic? Yeah, it is quadratic. Yeah, it is quadratic. So if I turn off, I think I can only turn off P gamma. But yeah, first thing takes the place of the letter. So now I only have P gamma here, P beta. But we have a new thingy that we can change. This one. Maybe it's the other one. What I want to do is drag the direction here at this cubic one. Dragging this one doesn't help much with the practical case, I think. So you know it's P beta because it's beta from before P0 and then P1. But if I just drag it to the other side, it becomes P gamma. That's 0, 1, and then that one. Still 1 point. It even becomes in the in-between point here. That's in between just. Yeah. This is parallel to the symmetry line of the problem. So by dragging this, I can specify the position of the rotation of the problem. I need to uncomment this one again. T1. Why is it commented out? No, I have D0 here. Draggable and all. This should work already. Cubic. Oh yeah, okay. But now it fills the fulfills the curvature. Can still do that. Maybe it's just this one. No, this is using the two directions. Huh? Don't want that. Shit, man. This is creating it from a direction vector, it says, yeah, and the curvature. I don't want to use the curvature. I want to use... Oh, wait a minute. No. Maybe I don't have that code anymore. Ah, this is the one. I had it separately. So determine a quadratic Bezier going through 3 points and a tangent in D0. It's just a separate curve. So ignore the cubic Bezier. This is again a quadratic Bezier. And it is going through 3 points, P0, P1, and now P comma. And the direction is fixed. The direction is wherever D0 is pointing. So it's really a parabola. This is rotated parabola. Until you try to do something like this, that's not possible. I'm not sure how useful it is though, because I don't know. It should be useful. I think it is the normal way that the most simplistic formulas that people use determine the derivative in P1. For example, if I if you see this thing as a real parabola, well, like which it is if I just, you know, make it vertical. And then the distance from here to there is equal to the distance from here to wherever this one is. So I have to move it really far down now, which I can't do. Oh wait, I can move P1? Ah, I can move P1. Oh, I can move P1. Or I just have to do this one a little bit more like that. Now I can do it. So if you set the parabola straight up, kind of like this, and then, okay, let's put this on here. And that, so from P0 to P1 now is a distance of 2. And then this one is again a distance of 2 in terms of x. Then, if you draw a line from P0 to P gamma, that line has the same slope as the tangent in P1. My main problem with this is that it only works if the x distance, or rather the distance from here to there, equal to the distance from here to there, which is then measured perpendicular to the position of the curve. But I don't know that. I just have a data point. I mean, it could be there, dude, whatever, yeah, or there. And now, of course, if I draw a line from here to there, it's no longer parallel to the tangent here. Plus, I wouldn't even know how to measure the distance. Because I don't know, symmetry line like this. And I have to measure it in that way. So from here to there is P1 and then the same distance. And then we go down and we end up exactly there, of course. But yeah, you can just move it here. So you can move it along the parabola without changing the parabola. Place it there. Which means if I move this along the parabola doesn't change shape. But this line from P0 to P gamma rotates, while the tangent is the same. So clearly not parallel anymore. I don't know, you see commas there. So for a starter, I want to not be restricted by the demand that this data point is for an equal distance of x, which means the equal distance of t, which means that t must be 2, because t goes from 0 to 1, and then t is 2 is, yeah, I don't know, just a fixed point here on the parabola. But I can have any point along the parabola. But this code, as you can see, just draws it. So I know wherever I put this point, I just know the derivative in this point. I just know it. So that's much better. Therefore, I want to use this. I want to have the derivative in P1 as a function of P0, P gamma, well, P1 of course, and the direction in P0. No, I don't. No, maybe some points. Well, it's fast enough, this code. The useless curvature. No, give me this parabola anytime over the quadratic Bezier curve. In terms of being a better fit. This one might be one order higher, a third degree thing, instead of a 2-degree thing. But both go through all 3 points. Both have the same tangents here. I'm just ignoring the curvature. This thing, this one tries to fit fits curvature here as well. Anyway, I think this one is useful. So I want to be able to fit a quadratic Bezier through 3 points and a direction. And here I can move them both, so yeah, they're really free. And that's really weird as well. It's again weird. Two variables, 3, 4, 5, 6, 7. Huh? While the quadratic Bezier has only 6 variables. So how can I enter 7 variables and fit 6 to them? Almost perfectly, until you try something weird like this. I'm not getting it. But yeah, so I should go to bed. It's almost 1 a.m. So I'm returning a boolean because sometimes there is no solution. This is kind of shitty enough, I think. No, it's not. Sorry. I was thinking about quadratic. I mean, it's a cubic one, and I want a quadratic one. So I thought, well, that just means that the matrix, the last coefficient is 0. But for the control points, it just means that these two are the same. If you put the both control points at the same point, then you have a quadratic one. The feeling I didn't do much, although I started late already, but still. Initialize quadratic Bezier curve from one of our data points. What else do I need? We need to actually be able to plot it, of course. Although that's maybe then a derived class. So I have most of my classes I have 3 times in 3 different namespaces. And this namespace is more for the pure mathematics. Nothing to do with cairo. So let's first concentrate on that. So I think that if I fit this one, you know, then I can get the direction. I can't get the direction yet, so let's add accessors for that. Although I can. That would be the velocity at the direction of the velocity at t is 1. 0 and 1. But, you know, it's kind of silly to do all these calculations, maybe. Shall I just do special case? So usually an input, so kind of silly to return that, but okay. Let's call this a D0. Can do that inline, I suppose. So that is this formula with t equals 0. So this is 0 and this is 0. So we have minus 3.0 times that plus 1 times C1. This is 0, this is 0, this is 0, this is 0, and this is 0. So this is the velocity at t equals 0. And then I need to get the direction from that. Well, 3 times a vector is a vector, plus a vector is again a vector, and if I construct a direction from a vector, don't tell me I can't do that. What? I think I meant this one. This is the only one that divides it by the length. Yeah. From to. A vector has a direction, which just constructs a direction from one point. Yeah. So I could do that directly, I guess. Convert vector to a point and then pass that. So how dirty is that? Change direction here into a point. Then it is a point, and you try to pass a point to the direction, so then you get the same thing. No, I don't think I gain anything with that. This direction is already by value, so it's temporary. If you return a temporary from a function, then you get copy elation. The copy constructor is not called, it's just going to be constructed right in the memory space of this return thing. It's probably the same thing. And this reads much better, of course. Let's make this a temporary as well, otherwise it only vanishes during optimization, or do I not care? Like, yeah. Why would I even say that it is the velocity, you know? You can just do a vector of that dot direction. Yeah. This one is harder. -3 times P0, but not really, because you have to add 2. So now it becomes 1, so it becomes +3. But then again, minus the square. Oh, wait a minute, so it's just +1. Oh, that becomes 0. Interesting. Let me try that again. -1. Oh, this is t minus 1 squared. It's 1 minus t squared. I have no idea what it is. -1 plus 2 times 1 is 1. Minus 1 squared is 0. Start over. And here we have 1 minus 4 plus 3. Also 0. Scary. This one is -1. And this one is P3. This one is even simpler. It's almost hard to believe. T is 1. Well, if this formula... Oh, there's a 3 here in front of it. No, it's not. Yeah, yes, it is. This 3 applies to everything. Okay. So this one is wrong. It is 3 times 3 times, and then we get -1, and here a +1. And then we get something that looks at least more symmetrical, because this is also 3.0 times something. Start from this side, so that's 3 times 1 times P3, so that's P3. And then here we have 2 minus 3 is minus 1. So that is 3 times minus 1 is minus 3C2. So the minus 1 that we see here now, it just appears there. And this should still be 0. Yep. Yep. Well, at least now it's more symmetrical looking, and then I'm more inclined to believe it. Why is the print on not defined here already? No return type. To be implemented. I'm gonna go to bed. Tomorrow, in the evening again, because during the day I have to do stuff. So Kotaro, good night. Thank you for helping. Purple Penguin is here. Let's stop the stream quickly. I hope to see you again, Kotaro. Bye bye. Bye bye, everyone.